allows a more optimized way to map the analog read from the 10K trimmer pot. And so what happens now is each coil that controls clockwise and counterclockwise movement is controlled through a delay function that's directly correlated with the mapping analog function of the trimmer pot. And so it's controlled with two push buttons, switch 1 and switch 2. When switch 1 is depressed, you can see, and switch 1 is going to be depressed and held down. And we have continuous motion, and this motion will keep going on forever until I stop pressing the switch. And the same with switch number 2. This is counterclockwise, and you can see on the LCD monitor it's showing counterclockwise. Switch number 1, clockwise motion, and the analog mapping right now is 981. Obviously we have 0 to 1023 for our value, and I sped the program up only because it's a lot more exciting to watch than what it's really supposed to be moving at, because it is going to be installed in a Raman spectrometer, which the steps are extremely small. But I just wanted to demonstrate how this program, this rewritten program, works now. And another feature of switch 1 and 2 is it has a stop and run feature, which you just push and release, and it automatically stops. And you can see that feature. I'm just pushing and releasing. And you can see my prototype grading assembly that I made on the motor. I finally got my design piece in that I made from Sculpteo on FreeCAD. And I got the part in, and it fit perfectly on the motor. And so this is just a mock-up of what this would look like installed in the spectrometer, and what its function is supposed to be. As the light or laser beam enters the slit, the entrance slit hits the first mirror, I can adjust this rotating turret to choose the wavelength range within the spectrometer itself automatically. And since this is a representation of 3 different gratings, diffraction gratings, these would be holographic diffraction gratings of different line resolutions, and I could choose whichever one that I want. And this stop and go function is extremely useful for choosing wavelength range. So this is the new revision B upgrade of my project, my turret grading diffraction control program, and she works like a charm. And that's going to do it for this demonstration, and I hope you enjoyed that. And I have 2 links on my site, and one will be the link to the upgraded control program code for this, and the other one will be a link to the complete project files on Hackaday for the 3D printable Raman spectrometer. Alright, thanks a lot. Bye-bye.